Hello and welcome to section 3.1b, exponential functions and their graphs. And so in this section we're going to talk about compound interest, and the compound interest formula is this right here, and we go through and explain that the account balance, how this works is A is the account balance, P is the principal. The rate is usually given as a percentage, but we need to change it to a decimal. And then the number of compoundings is how many times per year, quarterly, yearly, whatever, and T is the time. So we're going to go ahead and do a couple problems here. And so what will happen is this. All right, so I'm going to go through and write a formula for this. And so I need to find the amount when I have a principal of 3,000. I'm going to plug in 1 plus, now my percentage rate, 6% as a decimal, over the number of compoundings, 4 times, raised to 10 years times 4. So that's my power. So if I go ahead and get this on my calculator, I've actually already typed it in, would look something like that. And if I hit enter, you can see that I get 5,442.6 cents. So 5,442.6 0.06 would be the amount of money that I'm making on this in 10 years. Well, that quarterly is 4 times a year. Monthly would be 12 times a year. I forgot to do this earlier. And daily would be 365 times a year. Alright, so if that's the case, then my next one, my A value would be 3,000 times 1 plus 0.06% over 12 times 10 times 12. So if I get that on my calculator, I'm going to hit second enter, which brings up everything again. If I arrow back, I'm going to put 1 and then insert a 2. So there's my dividing by 12. And then I get 12 here. Close my parentheses, and so I get 5,458.19. So $5,458.19 for a monthly. Well, let's see what happens if we do it yearly. If we do it daily, we're going to get 3,000. 1 plus 0.06 over 365. Raised to 10 times 365. Alright, so that answer, second enter, I'm going to insert 365, 36, insert 5, so I don't have to retype the whole thing, and at the end it will be 365. Close my parenthesis, hit enter, I get 5,466.9 cents. So 5,466.9 cents. And so you can see there isn't much difference between compounding it quarterly versus monthly versus daily. So that's why, you know, your bank is probably going to do it quarterly, but what would end up happening is you're not going to get much difference, but it's money, and so there's just different rates. So what would happen if we compounded it continuously every month, every day of every year? Well, that would mean, and I'm kind of frozen here, alright, that would mean that you get this equation, compounding it continuously, and that this is same idea. This is just every moment of every day. So it's an exponential function, and my exponential function basically gives me that I have an amount, a principal. E is my growth rate, and R is the rate at which I am changing, and T is time, the amount of time. So again, R is a decimal, is a percent that needs to be changed to a decimal to use this. And so this should be balance if the interest is compounded quarterly and continuously. Well, there shouldn't be much difference between quarterly and continuously when we do this, and you'll see that when we do this. So we'll do compounding it quarterly is going to give me a little bit different formula. Remember, we have to use the old formula for quarterly, and continuously we're going to use our new formula. So let's talk about that. So if I'm going to compound it quarterly, so for part A, A, I have to use the formula A equals P times 1 plus R over N to the NT. And so that means that A would give me 12,000, just like we did in the previous example, 1 plus, this time we're using 3% quarterly, 4 times a year, raised to the 4 for 4 years. And so I would need a calculator for that, and it's going to be 12,000 times 1 plus 0.03 divided by 4 raised to the, I'm just going to make it 16 power, so I don't have to calculate it out, and it gives me something like 13,532. So 13,592 point, let's bring that back, 523.91. 523.91. So I would make some money on that one. So then continuously, part B would be the fact that I'm going to use this formula. It shouldn't be far off, but we'll see. So 12,000 to the E raised, I don't know why I'm using parentheses, just because they use parentheses there. Percentage rate is still 3%, and now my T is 4. And so that is a 4, not a 9. It's a 4. And so now, getting my calculator, I'm going to say 12,000 E, so that's second ln, E to the 0.03 times 4. And you will see that this number, 13,529.96, so 13,529.96, and 96 cents isn't that far off. So you're going to need these formulas for class, and we're going to practice this a little bit more. So come to class prepared to ask your questions.